Okay, so hi everyone, I'm Matt Falkenhagen. I'm an engineer at Google, and I'm going to talk today about pre-rendering. It's an effort that a team of us are working on, including me, Kinuko, Linchi, Hiroki, and Takashi. There's also many adjacent teams and people working on pre-rendering and interrelated things that it builds upon and depends on, but are too many to list here, but are critical to the effort. So first of all, what is pre-rendering? The concept is quite simple. We try to load web pages before they're needed so that when they are needed, we can show them instantly. As you may know, Chromium did have pre-rendering in the past. We removed it about 3 years ago in favor of no-state prefetch. The reason it was removed are many reasons, but it's quite a difficult thing to get right. No-state prefetch does a simpler form of it where it prefetches a URL, scans the contents of that response for other URLs that are likely going to be requested by the page and fetches those as well. The fetches are just normal fetches that are expected to populate the browser's HTTP cache, but there's no state, there's no page that's created or rendered or a script executed during this. So once the scanner finishes its work, then the render gets thrown away. So there's no state that persists after no state prefetch beyond what's in the browser cache. I did not mean to go there yet. And then so what we're trying to do now is bring back some of the pre-rendering functionality and actually do a pre-render of the website or the web page. And the reason we want to bring it back is it allows for more of an instant load when it does work than no state prefetch is capable of adding. So looking into what actually pre-render is, we can think of it as 3 steps. We have to predict what URL is useful to be pre-rendered, and then we have to prefetch that URL, and then we actually have to load and execute that URL and do pre-rendering. So first of all, prediction, how does Chrome know what to pre-render? There's currently 2 triggers we use today, and these trigger no state prefetch. One of them is the link rel prerender tag. This is how a web page can tell the browser that it recommends it to prerender or prefetch a given URL. And the specification gives the browser a great deal of latitude in what it does when it gets this hint. And Chrome today does no state prefetch. Chrome also triggers this prefetching on the Omnibox if the input in the Omnibox is such that Chrome can think with a high degree of likelihood that you're going to visit a certain URL, it can go ahead and trigger no state prefetch then. So we'll talk about prefetching a little bit. So this is even before we actually try to pre-render something. When we fetch the web page, there's some things we have to consider. Just fetching a URL can cause issues with privacy and with side effects. So especially in the link rel pre-render case, one page can tell Chrome to load a cross-origin URL. And especially if there's cookies on that request, this can be a privacy concern. You can also imagine there's side effects by just fetching a URL. For example, if we prefetch a logout page, that can mutate the state that you have for that website. So these are things we have to consider. Cookies are a key part of this, we think. So possible mitigations are going to be probably around what we do with cookies. So we might, for example, try to trigger only when you don't have cookies for the site, or possibly strip out cookies when we're able to. And again, these are things that no state prefetch also has to contend with. But we have to keep in mind as we try to increase the cases where we prefetch and pre-render websites. So let's look into how pre-rendering actually works. So as before, suppose you have a page, it has something on it that triggers pre-rendering. It has a link rel pre-render tag, for example. Once we trigger it, the browser is going to start a navigation to the pre-render page. So we still have the main page here. In a hidden background place, we're starting to navigate to the pre-render page. Once we have the contents of that, and then we start loading it. Now we have the main page and the pre-render page coexisting. They're both loading things. They're both executing JavaScript. Later on, when we want to actually use the pre-render page, this is what we call activation. So we activate the page. After this, now the pre-render page is the main page, and the former main page is not illustrated here. So this is illustrating something called the multiple page architecture, which there was a previous talk on at BlinkOn, which you can look at it more details. This is how we can have multiple pages associated with each other in a single web contents or a single tab. So you can check out that talk for more details. The key here is that pre-rendering is going to build on this architecture. So going into more detail about what actually happens in what render processes when we do this pre-render process, pre-rendering process. So let's suppose we have a page in a render process with the link rel pre-render tag. This tells the browser process about it, and this triggers pre-rendering. So the browser process can say, I'm going to start pre-rendering the URL that was given. So it creates an object called prerender host, which is going to be responsible for owning a pre-rendered page. It does a navigation with using this host, and this acts like a normal navigation, much like normal navigation. It commits the response to the render, and the render goes off and it does loading and executing script for this page. And here I've got these in two separate render processes. It's possible that they can be the same ones, but for example, in a cross-site pre-render, they will likely be different render processes. So later on, an actual navigation occurs, and when this happens, the browser first looks through its pre-render hosts that it has in this tab and sees if there's any for the URL that it wants to navigate to. And let's suppose it does, the navigation is to the URL that was pre-rendered, so it's going to activate those web contents, or it'll activate the page inside those web contents and make it the main page. As part of this, it's also going to send a signal to the page that was activated, and this will be a web exposed API that we'll have to figure out the details of, but it'll allow the page to know that it's now been activated. So we've talked a little bit about dangers of pre-rendering, and now we'll go into more detail about what the risks are and mitigations are. So basically, we want to be careful with what pre-rendered content can do, because if we allow it the full capabilities of an active page, it can cause undesirable side effects. It can break some privacy guarantees. So we do want to restrict these pages. The problem is, if we do too many restrictions, we could possibly break a page because it won't have the capabilities that it's expecting to have. So one approach to this is we can offer APIs that allow sites to opt into pre-rendering. And by opting in, they sort of can be expected to know what they are and what they are not allowed or what they are capable of doing. On the other hand, that would limit what we can actually pre-render. So we want to also experiment with pre-rendering some of the web, even without the explicit opt-in, and seeing whether this can work by doing some sort of best effort pre-rendering that does not break the page. So sort of what adaptive pre-rendering is observing that sort of the restrictions and behaviors of the pre-rendered page are going to vary by the conditions of the pre-render. What triggered it, whether the site opted in, whether it's same or cross origin, and things like this. So to go into more detail of this, and this is just illustrative and ideas and nothing finalized or confirmed yet, consider two cases, a no opt-in case and an opt-in case. The above row is opt-in and the below one is the above row is non-opt-in, the below row is opt-in. And also, for simplicity, we'll say that these are both sort of cross-origin ones, so we're a bit worried about privacy here. So in the opt-in case, the no opt-in case, what can it do with resource requests? What can it do with network and fetching? For the main resource, as we saw earlier, that having cookies could possibly be problematic. So we might perhaps say that we would only trigger this when you don't have cookies for that site. Even if we do that, the site can be, the page can request cross-origin sub-resources, which possibly have cookies. So what we might do here is strip out those cookies. But of course, that has a risk of breakage of the site as well. So when we experiment with this, we have to be careful and see whether it's actually a viable strategy. There's other cases like for iframes that are cross-origin. We could perhaps say we just don't load those until activation, at which time it would have cookies available. And then in the opt-in case, we can do more. We can just say, yes, you don't have cookies available, and the site can be expected to be aware of that because it opted into this this contract. And then upon activation, it would get a signal to say you are now a fully active page, and it can make the fetches that it might previously not have made because it knows that it now has cookies available. And then in the right column, let's consider storage or other powerful APIs the site might try to use. In the no opt-in case, we don't want them to use these APIs, but we also don't want to break the page if it tries to use them. So we can consider two different strategies, perhaps if the API is asynchronous versus synchronous. In the asynchronous case, we can try to just defer processing that API until activation. So we just delay it. And from the site's point of view, it's just an API that takes a long time. For synchronous APIs, we won't be able to do that sort of thing because it would block the page completely, possibly block the render process completely. So in that case, we might just not be able to handle this, and we might have to cancel pre-rendering. Whereas in the opt-in case, we can do more. We might just block these APIs, throw an exception, and the site can be expected to deal with it. It may also be more ergonomic to just defer silently in some cases, so that's also an option. But again, on activation, the site would get that signal and it would know it can use the APIs that it wanted to use at that time. As part of all this, we do have to expose state to the page so that it knows whether it's being pre-rendered or not. And that's an API that we're also have to consider how to design and expose. So that's a lot of like moving parts and different configurations. So how are we actually intending to proceed with this experiment and roll it out? Our first milestone for now is try to run an experiment triggered on the existing link-rel pre-render API. And this is considered a non-opt-in case because the site that is being pre-rendered might not have sort of agreed to being pre-rendered. And so the point of the experiment is to sort of validate the implementation, check the performance, see if things break and things like this. And we don't really know how far it can actually go in terms of shipping. It's possible it will just stay in experimental form. It's possible if it goes well, we could potentially ship it in some form. And then further milestones will support more of the new APIs for triggering and opting into pre-rendering. So we talked about restricting APIs and capabilities of a pre-rendered page, and this will go into more detail about how we're going to do that. So one observation is that most of the powerful things a page can do, it can do via Mojo interfaces that it gets from the browser process. And what we think that means is if we restrict the Mojo interfaces that we give to a page, it's a key way to control that page's capabilities. And this is an interesting difference from the legacy pre-rendering days because those were before Mojo was widely used in Chromium. So let's look at how this works. Normally, when a frame wants to have access to a Mojo interface, it will talk to the browser processes, its corresponding browser interface broker, and ask for the interface. Browser interface broker has a map basically saying, given this interface request for this interface, run this callback called a binder. So when it runs the binder is expected to bind the corresponding receiver to an implementation of the requested interface. And once that happens, now the page has access to that interface. So we think this is a good spot to control Mojo interfaces that the render can have by controlling when and whether to run these binders. So looking at how this mechanism works, we're going to add to browser interface broker, in addition to this map of binders, a corresponding map of policies. So the policies will say, given interface X, what should we do with it? For a pre-rendered page, should we delay it? Should we grant the interface, or should we do something more dramatic like canceling pre-rendering? So illustrated here, the page sends a request for the interface, and browser interface broker will look up, okay, for interface foo, what is its policy that was registered for it? And suppose the policy is to defer, which means don't run the callback yet, wait for activation. It'll store this request for later use. And when activation occurs, then we tell browser interface broker, the frame that you are talking to is now activated, so run your deferred binders. And once it does that, it'll run the binder as normal. And now the frame has a full access to the interface that it requested. So what are these policies that we're talking about? There's defer, which was illustrated just previously. This is actually the default choice. We think that almost all browser interface broker vended interfaces can just be deferred until activation. So if there's no policy, we will just defer it. And the other three ones here are exceptions to this. So one of the exceptions is grant. We would use this for an interface that we think pages are going to need in order to do a meaningful load during pre-rendering. So if there's any interface that meets that criteria, we would grant it. We don't actually have a good example of one now, but if we do discover one, it would be grant. Cancel we would use when we can't defer and we also can't grant. So we don't want to grant it because it's too powerful. It would allow pre-rendering to do something we don't want it to do. But we also can't defer it because that would break the page. So an example of that is a powerful interface with synchronous IPCs, because if we delay on those, it locks up the entire page. And then finally, unexpected. These are for interface requests that we don't expect to happen during pre-rendering. So this is just a assertion against that that assumption. And so this is not all there is about Mojo capability control. Some other interesting points to note here are that there's some interfaces that are provided by embedders. So what that means is embedders, if they need to, we're going to have to expose the policy map and policies to embedders. So they will have to know what they want the policy to be for the interface that they're registering if it's requested during pre-rendering. There's also interfaces that are not on browser interface broker, and so we have to figure out what to do with those, possibly moving as many as we can to this centralized point. There's also interfaces that go the other direction, browser to render, and there's also IPCs that are not Mojo IPCs. So we have to look into these as well. So going into just some more challenges and issues that we consider as we're designing and implementing this. One is what we do with metrics. So how do we define the core web vital metrics in the pre-rendering world? So longest contentful paint, first input delay, and layout shift. What do these mean? Most likely, we're going to measure the time from activation to when the milestone is considered done, as opposed to when pre-rendering started. We also have to consider how we expose the timing information to the web page with the performance timing APIs. So again, is time 0 going to be navigation or activation? Most likely activation is the natural one, but what do we do with timings that happen before activation? How do we expose that to developers? And that's something that we'll have to consider. Probably we can start out just like clamping the timings, like making it look like it happened it cost no time to do. but we're going to most likely have to expose these in a sort of really supported way, and perhaps by adding new fields and data to these APIs. We also have to be careful about how we log metrics so we don't confuse our current pipeline. So right now, UKM ties several metrics to a single page load. And in the pre-rendering world, we might get some strange inconsistencies, like if we see the time it took to round trip the server being more than the time that it took to reach the LCP milestone, that might confuse our analysis. So we have to be a bit careful here. Another consideration is lifetime of the pre-rendered page, like how long do we continue pre-rendering before it's used? So if we just leave it running forever, it's possible that this can start breaking the site, because especially if we're doing this, if we're deferring a lot of things, just making it look like things take a long time, that might trigger timeouts on the site, it might break the site. So we have to think of what our strategy will be here, perhaps having sort of time-based timeouts of how long pre-rendering exists, and or maybe if it reaches some milestone like load finished, we can freeze or pause the pre-rendering. So yeah, so this slide lists some ways you can follow up with pre-rendering. You can view these slides later. And there's also other talks at this BlinkOn related to this theme, so you can check these out as well. And that's all the information I prepared. So thank you. And we have some time for questions now.
So sync IPCs make a page ineligible for pre-rendering, is that correct?
Not ineligible, but when we encounter a page trying to use an interface with sync IPCs, we're probably, if we wanted to defer that interface, we would probably need to not defer it, because that would lock up the page. So we would either cancel pre-rendering or think of a more graceful way to handle that.
Do we have a rough idea of how many pages would fall into that category, or you would ultimately use a sync IPC and therefore not really reap the benefit of pre-rendering?
Yeah, I mean, that's something we're looking into. I don't have a number on hand though. And when we start our rollout of the experiment, with these policies, we'll see like how many pages ended up canceling pre-rendering and for what reason. And if that's, very high, we could sort of look into other ways to handle those.
Gotcha. And then so we have like the for the policies, cancel pre-rendering and then crash the renderer. Are we only planning on crashing the renderer? Like does that basically imply that the renderer or the pre-rendered page has done something malicious? Or like can we reasonably be sure that it's not like due to our mistake that we're crashing a renderer that might host other live pages?
Oh, so we don't plan on crashing the renderer.
Oh, okay.
For one of them was the unexpected one. For the unexpected policy, that would crash the renderer, but that's kind of just like a detect, basically. Like, we don't think that's interface request is going to happen. So our assumption was wrong, so we'd crash the render then. But in the course of a normal, we basically don't expect to crash the render. If it does happen, something went wrong with our assumptions, and we would fix that.
Yeah, I just wonder if that could cause a lot of confusion if it ends up crashing a renderer that multiple like other live pages are being hosted in, assuming pre-rendered pages are not hosted in their own process.
Right. So yeah, that's we don't intend to crash renders. We would be able to stop a pre-rendered page. We can cancel pre-rendering without crashing the render. The crash of the render is for does something happen that we did not expect. It's like a decheck in the code.
Right. I just want to, yeah, that makes sense. I just worry that like incorrect assumptions might lead to more crashes than.
But we do that we do that already, right? Like the browser process routinely kills renders if it gets IPC messages that are malformed, and this is or are arriving at the wrong time, because this indicates either a browser bug in Chrome or an exploit in progress. And either way, like
or an incorrect assumption, right?
Well, right, but we like we do crash the browser if we have a security like related assumption that was wrong.
Yes. Yeah, that makes
Right.
sense.
Like we'll get a crash report for this, and we should figure out whether it's like something that we missed and we should fix it. But like there's lots of other places where where you call report bad message in the browser.
Yeah, I just have one in my head recently where like we made an assumption. We're like, this will never happen, so we crash the render. It turns out it happens a lot, and we're making a bad assumption. But yeah, I mean, I agree. There's like precedent for this, and yeah, that makes sense.
Yeah, thanks. Sorry, I see. I think we're officially out of time, but we could probably use the buffer time for some more questions. I see Christian, you have your hand up. Did you want to ask something?
Yeah, great talk. Thanks for doing it. I was wondering about sort of ahead of pre-render. How do you decide which page to pre-render, and then do you pre-render more than one, and do you put in a limit? Is the limit based on memory usage, or is it just the number of pages you would pre-render for any given page? So that's one question. And then I also had a question about how does safe browsing plays into this, where potentially going to a site that's malicious, or rather potentially being pre-rendered to a site that's malicious, would be a problem. So two different questions.
Right. Yeah. Thank you. So two questions. The first one was, how do we decide what to pre-render, and like how many pages would we pre-render? So the triggers on pre-rendering that we're going to use the same ones as no state prefetch to begin with. So one of them is the link rel pre-render tag. Basically, when we see that tag, we're planning to trigger pre-rendering. We're probably going to cap it at perhaps one pre-render just to start with. We would not have multiple pre-rendered pages, at least for a single tab. Doing more than one may be possible, but maybe just to start with one. And then the second question about safe browsing. Yeah, so safe browsing is an example of a navigation throttle. I believe it's implemented as a throttle that runs before navigation. And this is something that we're going to have to integrate pre-rendering with. So we expect to run the throttles basically correctly and have them run before the pre-render, and also have them run before activation. So the safe browsing throttle should catch the pre-rendering for a bad site and stop pre-rendering.
Some of it is asynchronous, and we handle it sort of later. Well, Eric, I think Eric Anderson was on the call. He can probably explain that in more details. But we have these asynchronous cases where we load the page and then throw some UI in front of the user about the page being potentially malicious. How does that happen when that's a page that's being pre-rendered? Given that you can't throw UI in front of the user about that page yet.
I see. Yeah, probably things that, well, yeah, I could imagine different ways we consider it. Probably things that would throw up a UI that we expect to be handled synchronously by the user. We would have to just cancel pre-rendering in that case. If it's a UI that we can wait on, we might just sort of hang pre-rendering until the activation starts, and then show that UI before we actually proceed with activation or something like that.
In the specific case of safe browsing, I would expect users not to run into it very often when they're going to good websites. That's sort of being the point of safe browsing. And so I don't think it would be a great loss if we just cancel pre-rendering if we get a safe browsing flag on it.
I think you have to be put right. You have to do that.
Your malicious pages will just load slightly slower.
That's a good point. Were there other questions? I saw.
I was just curious what your timeline was for your first milestone. Like, what are you guys thinking about how long it'll take to get to that?
Yeah.
And I also was curious if do you have documentation somewhere that lists like, here are the APIs that we think are going to be the blessed APIs versus these are all the things that we're going to block, right? Because you put up the sort of the table of the opt-in and not opt-in and what'll be allowed. And I'm wondering if that's going to be listed somewhere in short, in a more detailed place for people to go look at that isn't some spec document.
Yeah, thanks for the questions. So first of all, the timeline of the first experiment rollout, it would be next year sometime, possibly Q2 if we are fast Q1. Rough timeline for that. As for the blocked APIs, I think Jeremy Roman's talk listed these out in more details, the web APIs for next gen pre-rendering. And maybe Jeremy, if you want, you can.
Yeah, I mean, we're going to we're going to try to evolve towards a set that is rational and that is well documented in spec and as well as in developer facing materials. Some of these early experiments that Matt talked about might use a more restrictive set and more not be able to handle everything that we'd like to ultimately handle. But in the longer term, we would like to converge towards something that's interoperable, understandable, well documented, that your tooling can help you with, etc. We're still working on this, both for the initial experiment, I believe, and for our longer term goals. So like these lists are very mutable at the moment.
So it's somewhat related to that question. Have you thought about having some kind of like reporting API to allow websites to understand when they're either causing pre-render to pause or getting canceled?
I have to say it's not something that I have thought about. I know we've thought about doing it in developer tools. Doing it as a reporting API, I don't know, Matt, if you've thought about it. My sort of initial thought is maybe that's something that we could do. I mean, there certainly is precedent for doing it elsewhere. We'd have to think through the privacy implications of that.
It makes a lot of sense to me, just personally. I think it would be extra effort to build on top of what is already a big effort, but I would like that.
It might have at least somehow reporting through the dev tools. I mean, it might help developers to know that they're being pre-rendered in terms of debugging your sites.
Yeah, I'd be really concerned about privacy issues with the reporting API because it will trigger a network request from the user's IP, and especially if that is giving away information about something which they never actually navigated to.
Yeah.
And maybe it's something more. I realize I'm just talking about, hey, add a bunch more work, but obviously, if there's some of the more aggregated type of things, maybe an origin could just kind of find out there are things that are preventing pre-render without maybe having individual clients actually report it.
There certainly seems like there's likely to be some sort of solution space there. You could imagine stuff getting rolled into like Crux reports or like who knows. But the direct answer is interesting suggestion, I think.
Well,
Yeah.
I do want to emphasize, like on dev tools, we just had a meeting this morning, like saying, yeah, this actually is something we wouldn't feel comfortable shipping without at least a bare minimum, like run your site in this mode or this demo page or something, and get console warnings for all the things that prevent you from pre-rendering.
Right. I think there's also precedent on exposing BF cache eligibility. So if it was not able to be in the BF cache, we're thinking about how to surface that as well. So kind of a similar thing. I think we're a bit over time. If there's any other remaining question, maybe one more, or we could just end. I think someone just came into my room. Okay, why don't we end it here? Thank you everyone for your time, and see you.